All right, so let's start. So we're looking at direct and inverse variation, and I'm encouraging persons to make an effort. The statements, when you hear them, sometimes they sound hard. Sometimes persons in learning mathematics, nobody wants to go beyond primary school. So if it is harder than anything we did in primary school, everybody wants to shut down the brain. Um, New does not necessarily mean hard. When something is new, it doesn't necessarily mean that it is hard. So let's start. This says direct and inverse variation, and it says if the relationship between two variables, x and y, is such that the ratio of corresponding values of the two variables is a constant, the two variables are said to be in direct variation. All right. Now, I want to take a minute and just try and see if I can explain. All right. Now, there are some blank pages. I think maybe from around page 23 or somewhere thereabout. So I'm going to go there. All right. I'll come back to All right. I'll come back to what we're reading, but I want to try and see if I can explain that. When are two things in direct variation? All right, let us say we have something like this. Pens. All right, and I'm trying to see if I can explain. And let's say I have books. All right, let us say this says 3. All right. 1, 3, 2, 6. Or I should have done it the other way around. All right, let's just stay for the time being. 2, 6, 3, 9, 4, 12. All right. So here we have two sets of values. Let us say the numbers on the pen represent the number of pens, and the numbers on the books represent the number of books. So for every book, there are what? There are 3 pens. So 1 book, 3 pens. 2 books, 6 pens. The other way around. 3 pens, 9. 3 pens, 9 books. 4 pens, 12 books. Now, earlier we said if the ratio between two values is a constant, those two values are in direct variation. Now, ratio, for example, this is a ratio, n to d. Now, n to d can be written as n over d. So a division can be viewed as a ratio. All right? So what I'm saying is that when I divide these values, I get the same answer. The two values are in direct variation. So for example, here this would be what? 3 divided by 1, then 6 divided by 2, 9 divided by 3, 12 divided by what? 4. So this is what we said. If you have two sets of values, like what I have here, pens and books, and every time you divide one set of value by the next set of value, by the corresponding value from the next set, and you get the same answers, the two values are in direct variation. So for example, 3 divided by 1 is 3, 6 divided by 2 is 3, 9 divided by 3 is 3, 12 divided by 4 is what? 3. You notice every single time I divide one value by the corresponding next value, I get the same number. Now, you get the same number. So in such a case, we say that the two numbers are in direct variation. So in other words, this is true, the number of books is equal to 3 times the number of what? Pens. The number of books is equal to 3 times the number of pens. I see this number 3 here is this number 3. The number 3 there is this number 3, and this is your what? Constant of variation. All right. Now, all of this what I just wrote, you don't need to write. What I'm trying to do is give an appreciation of the statement we read earlier, which says that if the ratio between corresponding pairs of values of two sets of number is a constant, the two sets of numbers are in direct variation. Here I have the number of books and I have the number of pens. Every single time I divide the number of books by the number of pens, I get 3. It means that the number of books and the number of pens, they are in direct variation. All right? Now, fine. Hopefully, as we progress, you won't have any problem. So, what page are we at? All right, this is the page that we're on. What page is it? This is not the new book, it's the old book. We're at page 111. All right, so let's go, no, it's not page 111, page 110. So this is the statement I made earlier. I said, if the relationship between two variables, x and y, is such that the ratio of corresponding values of the two variables is a constant, we say that the two values are in direct variation. So here, whenever you divide the corresponding values of y by x, you get k. Every single time we do it, you get k. Just like how in the example a while ago I showed you, every single time we divided the number of books by the number of pens, we got what? 3. Here, whenever you divide the value of y by the value of x, you get k. In the example, when we divided the number of what? Books by the number of pens, we got what? 3. If whenever you divide corresponding values of the same variables and you get the same answer, the two variables are said to be in direct variation. Let's have a look at the next statement. The next statement says, therefore, the relationship C varies directly as D, or A varies directly as the square of R, are represented as C over D is equal to K, or C is equal to KD. A over R squared is equal to K, or A is equal to K R squared respectively. The constant K is called the constant of variation or proportionality constant. All right, as I said, you're going to have to do a little thinking. And as you get older and as you get exposed to different material, you're required to increase your thinking level. All right, I'm going to try and see if I can explain that statement. I'm going down to the blank pages where I was a while ago. All right. So this is the statement we made. The statement says C varies directly as D. That's one statement. The next statement was A varies directly as R squared. Those are the two statements. But remember when we said, when two things are in direct variation, If you divide one by the other, you're going to get a constant. So for example, if C varies directly as D, it means that C divided by D is equal to a constant. If A varies directly as R squared, it means that A divided by R squared is equal to a constant. Now, if I put this over 1 and put this over 1, you help me. If I have one fraction is equal to one fraction, what do I do?
Cross
Anybody?
multiply.
Cross multiply. So 1 times C is what? C.
Yes,
And
sir.
K times D, this is what? KD.
KD.
So this is called a variation equation. Let's call a variation equation. And let's go. If I have one fraction is equal to one fraction again, I'm going to cross multiply. This is A is equal to what? K R squared. This is a variation equation. Now, in your variation equation, K, or the K, which is the constant, is called the variation constant or proportionality constant. All right, that's what we were reading earlier. C would divide by D because that is what the definition of direct variation says. If when you divide two things and you get a constant, the two things are in direct variation. I'm just trying for you to understand. If you don't understand, I can try and program you, but it is best if you try and achieve some amount of understanding, especially for persons who are planning to do high levels of studies, which should be everybody. All right, so we're still into the introductory part of the lesson. All right, so this is where we started out. So we've read the first two statements. Now, the third one, this says, if the product of consecutive values of two variables, x and y, is a constant, the two variables are in inverse variation. Therefore, y varies inversely as x and r. Y varies inversely as x, and r varies inversely as I squared, are represented as xy is equal to what? K, or what? Y is equal to k over x. I square r is equal to k, or r is equal to what? K over I square, respectively. All right. So we're looking at inverse variation. So there are two terms. There's inverse and there's what? Direct variation. All right. I don't want to dwell too much on this. I don't want to talk about this either, because but let's just read it. Later on, I'll give you something that is easier to understand than what you're seeing here. But let's just read this. This says variation and algebra, and in bracket I have steps. Now, in a typical algebraic variation question, the relationship between two variables is defined as a direct variation or as an inverse variation. That's the first thing. When you're doing variation, the examiner is going to start out by making a variation statement. And the variation statement is either going to have the word direct in it, or what? Or inverse. It's either the examiner is going to say direct variation or directly proportional to, or is going to say what? Varies inversely or is inversely proportional. So whenever you're doing a variation question, one of these two words are going to be in the question. The word directly or direct or the word what? Inversely. What else? Um, Now, from this defining statement, the variation equation is written. So you remember a while ago, earlier where I circled an equation CD is equal to, sorry, C is equal to KD, and I said that that was a variation equation. We'll get into that. So from the variation statement, a variation equation can be written. Now this says at least one pair of corresponding values of these two variables is given to calculate the value of the constant of variation. All right, we'll get into that. Now, once the constant of variation is known, the variation equation may be used to calculate unknown values of the variable, of one variable for a given value of the other variable. All right, and we'll also get into that. All right, but what I want to start with is down here. All right, we're still in the introductory part of the lesson. All right, so at the bottom here, what we have is a table that we're going to complete. I'm going to help you, and you are going to what? You're going to help as well. Now, to the left, we have variation statements, and to the right, we have a variation equation. Now, the variation statement, C varies directly as D, is written like this. I won't do that one. That one is easy. I'm going to do the middle one. A varies directly as the square of R. The variation statement A varies directly as the square of R, as the square of R translates into this variation equation. A is equal to what? K times R squared. Two things the examiner mentioned. He mentioned A and he mentioned what? Square of R. So here I have the A and I have R squared. The only thing I put in is what? K, and K is called what? The proportionality constant or the variation constant. So you can try to do the top one and the bottom one. Down by the bottom, the middle one says R varies inversely as the square of I. Now, if the word used is inversely, so this is R, the word used is inversely, so this is K divided by what? I squared. So if the word used is what? Directly, if the word used is directly, the equation is what? A is equal to K multiplied by. If the word used is what? Inversely, the equation is what? K divided by. With that in mind, please try and complete the table. All right, so let's finish the table. So C varies directly as D. That variation statement translates into the variation equation. C is equal to K times D. The variation statement, Y is directly proportional to X squared, translates into the variation equation, Y is equal to K times X squared. So if the word used is what? Directly, it is K multiplied by. Now, down by the bottom, Y varies inversely as X. Translate into the variation equation, Y is equal to K over X. The variation statement, Y is inversely proportional to C squared. Translate into the variation equation, M is inversely proportional to C squared. Translate into the variation statement, variation equation, M is equal to k divided by c squared. So if the word used is directly, it translates into k multiplied by. If the word used is what? Inversely, it translates into k divided by.